Hello guys, welcome to geography class. My name is Simran Singh and I have 9 years of experience teaching candidates preparing for UPSC, IS and PCSC exams. The topic for today that we are to discuss today is the interior of the earth. This area today, the lecture today will include um, why we need to study about the earth's interior, what are the different sources that provide us information about the interior of the earth, the types of earthquake waves that are produced during the earthquake and the different layers of the earth. Okay, why we need to know about the interior of the earth? Number one thing is exogenetic and endogenetic processes. There are different exogenetic things, components like your air, water, wind that are responsible for the shaping of the continents. The endogenetic forces, that is the plate tectonics, the volcanism, the earthquake, they are also responsible for shaping these continents. Until and unless we don't know what is the interior of the earth and how it behaves, we can never understand why exogenetic and endogenetic forces are processes are working and why they are doing what they are doing basically. Okay, all geophysical phenomena, earthquakes, your volcanic explosions, they are ununderstandable if we do not understand basically why and how the interior of the earth is like. Okay, another thing why it would be important is there are different objects in the solar system, there are different things in the solar system, and if we want to know about different solar system objects and how they are from the interior, they might be from the interior, we should know that we should need to know about the interior. Remember our atmosphere, guys. When we talk about atmosphere, our atmosphere is something which was locked, very much locked inside our earth. It came out only when it was it degassed, it outgassed from the interior of the earth. It was locked inside the earth. So all those gases, all those things, carbon dioxide, monoxide, nitrogen, they were very much inside the earth and they have come out from inside the earth. Economic part of it, guys, mining activity, all those precious metals, non-metals, resources, if we really want them, we understand them, we want to explore them, we want to get benefit out of it, we need to know the interior of the earth. Now different sources about and that provide us information about the interior of the earth, guys. There are two different sources, guys. One is called a direct source, another one is called the indirect source. Direct source, that is mining, that is we drilling inside the earth. Remember one thing, guys, our capacity to go inside the earth is very much limited. uh, we have not been able to go beyond 16 kilometers inside the earth. That is because of the extreme conditions that are there. The pressure is there, the heat is there, that does not allow us to go very much deep. But still, Kola mine in it's in Russia, and another one is in South Africa, diamond and gold mines. But rock samples from those places, materials from those places, and their chemical analysis, they provide us vital information how the interior of the earth might be like. Okay, and these are direct sources. Another is volcanic explosion. Remember, during a volcanic explosion, whatever the lava, the magma that comes out, that is from the inside of the earth. Just by taking that lava under microscope or your laboratory things, laboratory experiments, the scientists, the geologists, they have been able to identify the conditions inside the earth. So these volcanic explosions at times they also do provide us vital information about the interior of the earth. Another thing is, guys, gravity. Gravity is something which is related to your mass of the earth, and it varies basically at times at places. So gravity, this variation and everything, that also provides us clues to how the interior of the earth might be like. Guys, just because we have magnetism is something which is exhibited because we have the inner outer core combination, which is liquid and solid. We will be discussing it in the lecture only, and this provides us a very important source why we have magnetism and how that magnetism is like, and that magnetism is something which protects us from the outer radiation and everything. So this is another clue which does provide us directly or indirectly information how the interior of the earth might be like. Another thing is meteors, guys. Now remember, meteors are something which come from outer space, And during the Big Bang, when the Big Bang incident might have occurred, it's quite possible that those rock fragments could have been the part of interior of the Earth, or interior of different other continents, or planets for that matter, or stars for that matter. So they also provide us a vital clue to what exactly has caused or helped in the formation of the Earth. Another thing, guys, vital resource, the most important one, is the seismic activity. uh, Even if you like, now what is seismic activity? The vibrations produced. Earthquake is just a vibration. Earthquake is the moving and shaking of the earth. And remember the sonar, the ultrasound that is done when a mother is to give a birth to a baby, and we conduct that ultrasound to just to know in case the baby is fine, he's developing all his body parts perfectly. The same technology is used by uh, all the geologists and the scientists, the seismologists, when an earthquake occurs. An earthquake, what exactly is an earthquake? An earthquake is the vibrations and the release of energy during the movement of plates. Remember, plates, they are not like Swiss cheese and they will move like anything. They get stuck at places. Okay, and where the point where the plate motion is blocked is called the point of focus. And the focus is always beneath the earth, guys. Focus, the point where earthquake originates, where it is the plates get stuck, the stress and tension builds up, and when this stress and tension, this point gives way, it breaks and it releases energy into all the directions. And this release of energy is what is referred to as earthquake. The point directly above the focus on the surface of the earth is called the epicenter, guys. Is called the epicenter. Epicenter has maximum destruction, guys. Okay, it is the point of maximum destruction. Okay, focus sometimes is also referred to as hypocenter, guys. Okay, guys, the types of earthquake waves that are generated when there is an earthquake, these waves can be divided into two parts: body waves and surface waves. Guys, body waves, guys, they can further be divided into primary and secondary waves. Okay, earthquake waves, body waves, surface waves. Body waves inside the body, surface waves which comes to the surface of the earth. Body waves can be primary, they can be secondary. Okay, guys, primary waves, they are also referred to as longitudinal and compressional waves, and they're high frequency, long. They have long wavelength, and they travel in all mediums, solid, liquid, gases, and they are fastest and the first to come. Okay, they are fastest, they are first to come, and they can travel through solids, liquids, all mediums, or gases for that matter. The second wave type, the body wave type, is the S wave. Okay, it's also referred to as transverse wave, distortional wave, high frequency, long wave, and it arrives after P wave. So it is the second fastest in all three. Well, number one thing, it is the second fastest. But the most important thing that we need to remember here, that is the most crucial thing about uh, S wave, is that it cannot pass through liquids and gases. Okay, it cannot pass, because this, why this is important, because remember, our earth's core is made up of inner and outer core. Inner core is, guys, solid, it's solid. Okay, but outer core is liquid, and this outer liquid outer core, it doesn't allow the S waves to pass. So our information why the outer core is liquid, that is something which we have concluded from the missing up of or non-passing of the S wave from this outer core part. Okay. Okay, next comes here, and that is a point, that is the shadow zone. Well, guys, shadow zone is the zone or the area on the surface of the earth which will never receive an earthquake. Remember, whenever there is an earthquake, whenever there is an earthquake, most of the earth will be shaking, will be vibrating, but there are certain areas which will never experience any earthquake or wave or seismic activity, and that is called a shadow zone basically, guys. And S wave has a longer shadow zone in comparison to the P wave shadow. When it comes to P wave shadow zones, it's much smaller as compared to your S wave. And why the shadow zone is created? Because of the refraction, bending of the waves, and because the S waves cannot pass through the outer liquid core, the shadow zone produced by S wave is much greater. Some general science questions. Why, guys, sound waves travel faster in solids, liquid and gases? They travel fastest in solids. Okay, you can check that out, Google that out, and check why S waves cannot travel through liquids. This is the property of the wave that doesn't allow it, because the movement of S waves is like that, and that movement is not supported by liquids. That is why S waves never pass through your liquid. Now coming to the earth, guys. Remember, guys, the innermost part of the earth is called the core, and the core is made up of liquid and solid nickel and iron, often referred to as Nephi. Our Earth's gravity, our Earth's, sorry, not gravity, but the magnetism is because of this outer core and solid inner core combination. The liquid outer core is revolving around the solid inner core. Okay, and that is what is giving us our magnetism. Okay, above the core is we have the mantle. Okay, the mantle is plastic elastic in state, and it houses the asthenosphere. Asthenosphere is something which it has this all volcanic activity has its source in asthenosphere. Our Earth's maximum volume and mass is in asthenosphere. Okay, the topmost layer of the Earth is called the crust. Is called the crust or the lithosphere. The lithosphere or the crust is of two types: the continental crust and the oceanic crust, guys. Okay, the continental crust is often referred to as Sial. The common rock here is granite. Okay, oceanic crust is often referred to as Sima. Sima. The common rock here is basalt, guys. Very important, guys. Basalt, Sima, oceanic crust, continental crust, Sial. Okay, and the common rock is granite for that matter. Continental crust is much thicker as compared to oceanic crust. Continental crust at places it can be 100 kilometers thick, and oceanic crust 25 kilometers, 30 kilometers thick. And that is something about the different layers of the earth. Remember one thing, UPSC is not interested into such questions: what is the depth of the core or depth of the mantle? No, they will ask you questions: why is outer core liquid, and how do we conclude that the outer core is liquid? Outer core is liquid is concluded by S waves. And why is it liquid? Liquid, it is because of the release of pressure. Okay, a release of pressure results it changing its state for that matter. Okay, guys. Another question that is of some significance here is the Mohorovic discontinuity. Mohorovic discontinuity was asked recently by UPSC in prelims exam. Mohorovic discontinuity, basically it is between the crust and the mantle. That is the max you need to remember. Now, what exactly is a discontinuity? Discontinuity is a place, remember the movement of the earthquake waves. In a discontinuity is a place between two different layers of the earth. Between discontinuity, Morvic discontinuity is between crust and mantle. Actually, this is a zone where the seismic waves will become discontinuous. Either they will not be there, they will not be recorded by the seismographs. So what happens is the waves becomes abrupt here, and we refer to such a place as discontinuous. Continuity that is important is basically your referred to as Gutenberg discontinuity. Gutenberg discontinuity is between mantle and core. Okay, Gutenberg discontinuity. That's max what you need to remember. Nephi, I already told you, and we've discussed that. I'll not go into the details here. This is, guys, composition of the Earth's crust. Earth's crust, guys, oxygen, silicon, aluminum. Remember the sequence that might be asked. Sometimes they can ask. This is the sequence of your Earth's all composition for that matter: oxygen, silicon, aluminum. Can be asked again, guys. Thank you very much, guys. That's all for today.